one of the things that you need to look at when you're teaching physics is, and you really should do this, you should, let's say we're going to do sum of the forces, because that's what we're getting to, is we're going to look at multiple forces on one object, okay? And then we're going to calculate different things based on those forces. In order to teach that to students, though, you need to work out an entire problem and then pick out, this is a skill that I need to teach them. This is a skill I need to teach them. Because you can't always assume that a student knows certain algebra processes or trigonometry or different things like that. So, this skill that I'm going to teach you right now is how to do your trig identities. You're going to do a little trigonometry, and it's not as hard as a lot of people make it out to be. So let's start. And here's how it is couched in physics. I've got an object here, and I'm going to pull on it at an angle. Okay? And if I were to look at that, I could draw it, and I could come up with coordinates. Our students are good with knowing what coordinates are. So we could have our x and our y coordinate. Okay? Because I've got to get to that point. So we went over so many spots to the x, and we went over so many spots in the y. Okay? And that would give us our coordinate here. Well, if we look at that, what does that make? It makes a triangle, right? Okay. In physics, we love to use angles for lots of things, and we use this thing called theta to show us the angle. It's one of our symbols. Now, there are many different ways to do this. Some people teach SOHCAHTOA, some people teach some old hippie caught another hippie tripping on acid. I like to do it visually and physically, because that's how I learned it, and I think our students learn it best this way. And I look at that theta, and it looks like an eyeball to me. So that's really an eyeball. You know, we could even put little eyelashes on it, okay? It's an eyeball. And I want to know, I'm looking across the street, and I see a sign. Okay? I see a sign, and in trigonometry terms, we would term that as the opposite side. So we're going to learn that sine of theta is equal to opposite over hypotenuse. Okay? Because we're looking across the street at the sign. Now, cosine. Co. We run into that in video games with cooperative mode. When you're in cooperative mode in a video game, you're playing together. You're on the same team. Okay? You're on the same team in Halo playing against another team of 4. Okay? Or the same with Call of Duty and all that kind of stuff. Co is we're on the same team. Co also means share. Okay? So cosine. Cosine of the angle is, my eyeball is right here. Literally, this is like a projection. Our eyeball is right here at this point. Okay? What is right next to me? Where are my feet at? Where is my eyeball at? My eye, what's next to it? What's right next to it is the adjacent side. Adjacent is the fancy word we use in math. It's the side next to me over hypotenuse. Okay? Adjacent over hypotenuse. Okay. And then comes, so all of these, if you notice, is opposite to hypotenuse. Adjacent to hypotenuse. Well, we also have to have a relationship that does not have the hypotenuse, and that's the tangent of theta equals, I'll put a little divider here, equals opposite over adjacent. Okay, so how do I remember this? Sine. I'm going to look across the street at the sign, okay, and then hypotenuse. Cosine, it's next to me, it's my buddy, it's at my feet, and hypotenuse. Tangent. I remember it this way. Tan gentlemen need no hype. Tan gentlemen need no hype. Okay? So it's got to be the opposite over adjacent. So, now we are going to do a problem using this concept. Okay, so let's look at a sample problem, and let's say we're going to do our practice one. We have a force here, and I'm going to write these real short. Sine theta, opposite over height, cosine, adjacent over hypotenuse, and then tangent, opposite over adjacent. Okay? So here's our practice problem. We got 5 newtons. And I want you to find, and our angle is 30 degrees, and I want you to find our x, and I want you to find our y components of that force. So this is actually force in the x and our force in the y. Okay. So let's try. Sine of 30 degrees equals, okay, force in the y over 5 newtons. Okay, now we're just going to do basic algebra. Now I teach my students, sometimes we leave those, I make them write them the first time, and then as we do our math we will drop the units. There's problems with that, I know. But sometimes that's what we do. So, how do I do it? This is kind of that metacognition thing. We got to get our students to realize, what are we doing? We're looking for this. What's happening to it? Force divided by 5. So we've got to do the opposite and multiply both sides by 5. And the force in the y equals 5 times the sine of 30. And you plug it in and you get we'll have to calculate that in a second. Force in the x. Which would be better? What do we have to use? X is at my feet, so I'm going to use cosine. Okay? So plug that in your calculator, see what you got. Be careful when you're plugging these in your calculator that you're using degrees and not radians. If you want to go into radians with your class, I usually don't at first. They just have to be able to transfer them into degrees. Okay? All right.